Today we will be talking about pre-reducing, or as some people call it, canceling. This process is only used when we have a multiplication problem. You cannot do this in either adding fractions or subtracting fractions, only when you see a multiplication sign. Sometimes when we're multiplying fractions, if we multiply straight across 2 times 5 and 9 times 8, sometimes our numbers turn out to be really large and hard to manipulate to reduce your problem. In that case, it is easier to pre-reduce. When you are pre-reducing, you look at both the numerator, or the top of the fraction, and the denominator, the bottom of the fraction. Do you see a number on the top and a number on the bottom that can both be divided by the same number? Well, if I look at the 2 and if I look at the 8, I see that I can divide both 8 and 2 by 2. And I see that 2 divided by 2 is 1, and 8 divided by 2 is 4. This has simplified my problem. Now I'm seeing 1 over 9 times 5 over 8. And I repeat that process. Do I see a number on the top and a number on the bottom that can both be divided by the same number? Well, no, I don't see anything that they have in common. So at this point, we can multiply straight across. 1 times 5 is 5. 9 times 8 is 72. And my final answer is 5 over 72. Let's try that again. The second problem. 8 over 15 times 5 over 12. And again, do you see a number on the top and a number on the bottom that can both be divided by the same number? Well, if I look at the 5 and I look at the 15, I see that I can divide both of those by 5. Well, 5 divided by 5 is 1. 15 divided by 5 is 3. So now my problem has become 8 over 3 times 1 over 12. And we repeat that process. Do we see anything on the top and on the bottom that can both be divided by the same number? What about the 8 and the 12? Can we divide them by the same number? Well, I can divide them both by 2. So 8 divided by 2 is 4. 12 divided by 2 is 6. And now my problem has become 4 over 3 times 1 over 6. And we ask that same question. Is there anything, any number on the top and a number on the bottom that can both be divided by the same number? Well, if I look at the 4 and the 6, I can see I can still divide both of those numbers by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And my problem has become 2 over 3 times 1 over 3. And I ask myself the same question. Can I divide the number on the top and the number on the bottom by the same number? Well, no, I cannot. So now I know I've reached the end of my problem. 2 times 1 is 2, and 3 times 3 is 9. So my final answer is 2/9. Third problem. 25 over 36 times 24 over 35. And this is one of those ugly problems I was talking about. 25 times 24 is a large number, and so is 36 times 35. So it will be much easier to pre-reduce first. So if you look at the number on the top and a number on the bottom, can you find something that divides into both of them? So we look at the 25 and the 35. Well, I can see I can divide both of those numbers by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. And now I'm looking at 5 over 36 times 24 over 7. And we repeat the process. 24 and 36. Can I divide both of those numbers by something? Must be the same number. Well, I see I can divide 24 and 36 by 4. 24 divided by 4 is 6. 36 divided by 4 is 9. And now my problem has become 5 over 9 times 6 over 7. And I ask the same question. Can I find a number on the top and a number on the bottom that can both be divided by the same number? Well, what about that 6 and 9? Can we find a number that'll divide into both of them? And I see that I could divide 6 by 3 and I can divide 9 by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And now my problem has become 5 over 3 times 2 over 7. And we repeat the process. Is there any number on the top and on the bottom that can both be divided by the same number? And my answer is no. So I multiply straight across. 5 times 2 is 10. 3 times 7 is 21. And my answer is 10 over 21.